Case study: the Burj Khalifa's foundation design. The Burj Khalifa isn't just the tallest building in the world, it's also one of the greatest feats of geotechnical and structural engineering. Standing at over 828 meters, its incredible height demands a foundation system that can support enormous loads, resist wind and seismic forces, and adapt to the desert conditions of Dubai. This case study explores how engineers designed the foundation for the Burj Khalifa to make the impossible possible. The site and soil conditions. Dubai's soil posed significant challenges. The building site sits on a mix of weak to moderately strong rock, layers of siltous sands, and calcareous sandstone. These strata have variable strength and are prone to settlement. Moreover, the groundwater table is relatively shallow, which complicates deep excavation and can create uplift pressure. Understanding this complex geotechnical environment was the first step in designing a stable and safe foundation. Engineers carried out extensive soil testing, including borehole drilling, cone penetration tests, and pressure meter tests, to accurately model the ground behavior and plan accordingly. Why a deep foundation was necessary. Given the enormous weight of the structure, estimated at over 500,000 tons, shallow foundations like footings or rafts alone wouldn't suffice. Uneven settlement could lead to catastrophic damage, and shallow systems would not engage the more stable deeper strata. A deep foundation system was needed to transfer loads well below the weaker surface layers, reduce differential settlement, and provide lateral resistance. That's where pile foundations came into play, offering both depth and reliability for a building of this scale. Foundation type chosen. The final design consisted of a reinforced concrete raft foundation supported by a deep pile system. The raft itself is about 3.7 meters thick and spreads the building's load over a large area. Underneath, a total of 192 board reinforced concrete piles, each 1.5 meters in diameter and approximately 43 meters deep, anchor the structure into the ground. The combination of the raft and the piles creates a hybrid foundation system that delivers exceptional stability, even in the face of harsh conditions. This dual-layered approach effectively disperses vertical and lateral forces throughout the subsoil. Pile design and execution. The piles were constructed using the rotary drilling method, a technique well-suited to sandy and silty conditions. Engineers ensured full reinforcement of the piles, and high-strength concrete, ranging from 60 to 80 MPa, was used to guarantee performance under intense loads. Pile load tests, including static and dynamic tests, were performed before full-scale construction to verify bearing capacity and settlement behavior. Some piles were tested up to 2 times the design load to ensure safety. These rigorous standards gave engineers the confidence to proceed with such an ambitious structure. Handling groundwater and soil movement. Controlling groundwater was a significant concern during construction. Engineers installed dewatering systems to lower the water table temporarily, allowing excavation and pile installation to proceed without water intrusion. Additionally, waterproofing membranes and protective layers were used around the raft to prevent long-term groundwater penetration. Since Dubai experiences frequent temperature swings and minor seismic activity, the foundation was designed to accommodate thermal movement and absorb ground shifts without cracking or failing. Settlement and structural monitoring. Predicting and controlling settlement was crucial for the long-term performance of the Burj Khalifa. Finite element modeling and geotechnical simulations helped predict how the foundation would behave under various loading scenarios. Once construction began, sensors were embedded in the foundation to track movement and stress in real time. The initial design allowed for an estimated total settlement of about 25 to 30 millimeters. Actual measurements have shown the structure settling uniformly and well within safe limits, validating the accuracy of the design and analysis. Why this foundation was groundbreaking. The foundation design of the Burj Khalifa set a new benchmark for high-rise construction. It combined state-of-the-art engineering tools, high-performance materials, and deep knowledge of soil structure interaction. The use of a hybrid raft and pile system ensured both safety and stability, while innovative monitoring techniques confirmed its success over time. The experience and data gathered from this project now inform other super tall structures around the world, proving that when it comes to civil engineering, foundations are more than just the bottom. They are the beginning of greatness. Thanks for joining us here on Blueprint to Reality. If this deep dive into the Burj Khalifa's engineering fascinated you, give it a like and tell us what you'd love to explore next. And don't forget to subscribe for more incredible insights into how our world's most iconic structures are designed and built. Stay grounded, stay curious.